Hi, I'm Esther Stewart, Bedrock geologist with the Wisconsin Geological and Natural History Survey. Thank you for listening to this digital presentation about ongoing mapping in Jefferson County, southern Wisconsin, and the Ashland syncline project in parts of Ashland, Bayfield, and Douglas counties, northern Wisconsin. These projects have benefited from contributions of many folks at the Wisconsin Geological and Natural History Survey, including Carson Ames, Sarah Bremer, Pete Chase, and Pete Shepoister, as well as 7 student employees from UW-Madison and UW-Milwaukee. The photo on this slide shows outcrops of the 1 billion-year-old Nunsuch Formation, one of the rock units that underlies the Ashland syncline project area. The map on this slide shows the progress of 1 to 100,000 scale bedrock mapping in Wisconsin. Areas with completed bedrock maps are shown in green, while ongoing mapping is shown in purple. I'll start this presentation by recapping progress made over the past 2 years on the Jefferson County bedrock map. On this slide, Jefferson County is shaded purple and called out with the number 1. After summarizing completed work in Jefferson County, I will overview ongoing work in Jefferson County and the Ashland syncline project area. The Ashland syncline project area is shaded purple and called out with the number 2. Finally, I'll finish the presentation with a proposal for future work. As a reminder, the objective of the STATEMAP program is to establish the geologic framework of areas determined to be vital to the economic, social, or scientific welfare of the U.S. The Jefferson County project includes a 2-year effort to produce a bedrock geologic map, plus an ongoing 1-year effort to produce derivative maps and develop hydrostratigraphy for the county. The next several slides present progress on Jefferson County bedrock mapping, followed by an overview of the derivative mapping and hydrostratigraphy. On this slide, Jefferson County is located in southeastern Wisconsin and shown in blue on the inset map of Wisconsin. The map on the left shows Jefferson County, outlined in red, overlain by 7.5-minute quadrangles. Mapping of the 4 quadrangles shaded light green in northwest Jefferson County was completed in fiscal year 2019. Mapping for the remainder of the county, shown in dark green, was proposed for fiscal year 2020. The 2-year project will produce an updated geologic map at 1 to 100,000 scale, cross-sections, a database of updated stratigraphic contacts for wells, and updated unit descriptions. The figure shows the updated bedrock geology for Jefferson County. The geologic units, shown on the right, include the Ordovician Sinope group dolostone and Ansell group sandstone, the Cambrian Trempealeau and Tunnel City group sandstone, and the Precambrian Waterloo quartzite. These updated map contacts for the county are the primary deliverable for the project. Because the bedrock units in Jefferson County are almost entirely buried underneath up to some 200 feet of unconsolidated sediment, mapping was based on evaluating subsurface data from water wells and bedrock cores. There are 3 bedrock cores in Jefferson County, shown by the black triangles on the map. 2 of the cores were drilled as part of the 2-year STATEMAP effort, one last year in west central Jefferson County and one this year in south central Jefferson County. Collecting bedrock core allows us to directly observe the buried bedrock map units. This photo shows Carson Ames, WGNHS Samples and Lab Manager, working with UW-Madison undergraduate student Philsa to box the drill core we collected this summer for the project. This drill core started in the lower Ordovician Sinope group dolostone and ended at 575 feet below land surface in the Cambrian Mount Simon Formation. This core recovered nearly the entire Paleozoic section present beneath Jefferson County, including the Eau Claire Shale, an important regional aquitard that pinches out near the northern boundary of the county. In addition to core, Pete Chase has been working to collect new geophysical logs from high-capacity wells as those become available. There were only 3 modern, reliable geophysical log suites in the county before we began mapping. Over the past 2 years, Pete has logged 4 additional wells. The 4 wells with fully processed logs are shown by brown squares on the map. Logs for the remaining 3 wells will be processed and incorporated into the mapping in the next few months. Bedrock exposed in quarries, shown by pink diamonds, and geologic logs made by observing drill cuttings from wells, the brown pentagons, are the other main data sets used to make the map. Because there are relatively few drill core and geophysical logs in Jefferson County, we are relying more heavily on geologic logs from cuttings in our interpretation. Cuttings are rock chips that come out of a well as it is being drilled. The WGNHS receives cuttings in 5-foot intervals from well drillers. The glass bottles in the photo here contain cuttings that are stored at the survey's core repository in Mount Horeb. Survey geologists make geologic logs of the cuttings by looking at them under a microscope. The document shown on the slide is an example of one of the geologic logs recently completed for Jefferson County. I use these logs, together with the core and geophysical logs, to interpret the thickness and elevation of different bedrock units that are buried beneath Jefferson County. This interpretation is recorded as a database of stratigraphic picks, in other words, the elevation of the base of different Paleozoic stratigraphic units at each well location. The database will be published with the map and available to download from the WGNHS website. The elevation of the top of bedrock recorded in several thousand geolocated wells is used to interpret the elevation of the bedrock surface. In this figure, areas of high bedrock elevation are shaded brown, while low-lying areas are shaded blue. A significant bedrock valley is apparent in southern Jefferson County. This area is overlain by some 200 feet of unconsolidated quaternary sediment. Over the past several years, recent UW-Madison graduate Joe Rasmussen has worked with me to interpret the elevation of the top of Precambrian surface in southern Wisconsin, including Jefferson County. This effort was funded in part by STATEMAP as well as the UW Water Resource Institute. The figure here shows 100-foot contours overlying a hillshade of the interpreted top Precambrian surface. This interpretation is complete and will be submitted for publication through the WGNHS in September of this year. As part of the ongoing fiscal year 2021 mapping, I am building on the completed geologic mapping that I just described to produce derivative maps and a hydrostratigraphic framework for Jefferson County. Derivative maps include maps of depth to bedrock as well as the base Ordovician Sinope group dolostone and Ansel group sandstone. This is a one-year effort for the entire county. This image shows the elevation of the base Sinope group for Jefferson, Dodge, and Fond du Lac counties. I worked with WGNHS geologist Esther Stewart to integrate observations from recently completed mapping in Dodge and Fond du Lac counties with the Jefferson County interpretation. As part of a separate UW-Madison Groundwater Resources Institute funded project, Eric has used this surface to demonstrate a relationship between proximity to folds in the base Sinope group and the likelihood of detecting arsenic in wells. We have also interpreted a base Ansel group surface over Jefferson, Dodge, and Fond du Lac counties. That surface is shown here as 20-foot contours above a hillshade. The western side of the surface has greater resolution due to a higher density of wells that penetrate the base Ansel. The knobby character of this surface is striking in its resemblance to karst topography and supports an interpretation of karsting of the top Prairie du Chien group dolostone prior to deposition of the St. Peter Formation of the Ansel group. I am also working on year one of a 4-year project to map the buried bedrock units of the Ashland syncline, which spans parts of Douglas, Bayfield, and Iron counties. In case you're wondering, the word syncline simply describes the geometry of the folded bedrock in this area. The proposed map area is approximated by the blue rectangle on the inset map of Wisconsin. The map to the left shows the ongoing fiscal year 21 map area in dark green and future planned mapping in light green. This work will be based on observations of existing drill core collected for mineral exploration purposes and currently stored at the WGNHS core facility in Mount Horeb. The location of these drill cores are shown by the circled crosses on the map. The goal of this mapping is to evaluate whether the existing bedrock units, which are up to several kilometers thick, can be subdivided and mapped at 1:100 scale. This summer, Carson Ames and I amassed an army of geology students to help us characterize the core. This photo shows Carson with Patrick, Shazwan, and Filsa standing amongst the many shelves of drill core. Patrick, Filsa, Shazwan, and Katie, who is not shown here, spent much of the summer pulling core, taking high-resolution core photographs, and collecting geochemical analyses at 2-foot intervals along the core using the survey's handheld X-ray fluorescence instrument, XRF for short. My goal is to use the core photos and the geochemical profiles to evaluate the composition and distribution of the bedrock units recovered in the drill core. This image shows partial core logs and elemental profiles for 2 of the drill core. The depth scale is in feet relative to land surface, and the 2 cores are datumed on a carbonate-rich bed shown by the lower blue horizontal line. For both core, the image on the left is a graphic log based on visual inspection of the drill core. The curves to the right show elemental concentration with depth measured using the XRF. The elements shown are proxies for common rock types or minerals. For example, silica shown is shaded yellow in the track furthest to the left and is a proxy for quartz in sandstone. In the same track, titanium is shown by the green curve and is a proxy for the heavy mineral titanite, while zirconium is shown by the black curve and is a proxy for zircons. Note how the zirconium and titanium become more jagged above the pink horizontal line in each well. I am using observations like this to subdivide, map, and characterize kilometers-thick bedrock units. Mapping projects I've been involved with have resulted in several new publications, including maps published by the WGNHS and available for free on our website, as well as peer-reviewed journal articles and a master's thesis. Some of these publications are listed here. Finally, I'll wrap up by proposing to continue working on the Ashland syncline project for fiscal year 22. This area is called out by the number 1 on the map. Fellow WGNHS bedrock geologist Esther Stewart and I are also interested in leveraging STATEMAP to complete our mapping of the Baraboo Hills in southern Wisconsin. I look forward to discussing these projects with you in the breakout sessions. Thank you.